Hello, everyone. Welcome to our QGIS India Community Day July meeting. We've been trying to do this every month, and today we have an exciting line of speakers to take us through various use cases. We have a talk on NISAR data. A lot of you have been asking about NISAR data and how to work with those. So we have an expert from ISRO, Dr. Dharmendra Kumar, who will be taking us through NISAR data. We have Krishna with us, who's going to be talking about a new plugin that he has developed on accessing satellite data in QGIS. And then we have Manas, who's been also talking about a plugin he developed internally to automate a workflow. And as usual, we'll do some Q&A, and if we have time at the end, we'll do some discussions. For folks who are new to the user group, it's an online community. We have people from all across India, even outside India, everybody who's interested in QGIS and stuff happening in India. Please feel free to join. If you're not part of any of the communication channels, please visit the website in.qgis.org, and you can go and join those community. We've been growing this groups for last 6 months. LinkedIn is our largest community. We have pretty active Telegram group, so feel free to join. If you like to contribute, we have working groups within the user group where people are more actively involved in helping with the activities of the user group. We have folks doing helping with website design, content, event, organizing monthly events like this takes a lot of work. We have Kiran, Janvi, who are part of the events group, who's been helping put together these events. We also now have a translation group. Arvind has been leading that. So we're translating QField into Indian languages so that it's available in different languages. So if you want to kind of help out with any of these groups, please email this at qgis-india@googlegroups.com, and we'll connect you with the group and you can start contributing. We also have a member directory. We have 1,000 plus people on LinkedIn group, but we're not kind of listed as an official member of the group. This is just free to join. Just scan this QR code, fill your details. You'll be listed on the website. You can also say, I don't want to be listed. I just want to be a member, but I don't want to be listed. That's also an option. And again, this is great for networking. Often you'd find that, hey, I'm in this city. Who are the other QGIS India community members in my city? And you can come to this member directory, which is on the website, and you can also look at and connect with other users. With that, we can start with our feature presentations. I'm going to hand over to Janvi, who's going to introduce our speakers, and we can continue from there.
Good evening, everyone. So our first speaker would be Dr. Dharmendra Kumar Pandey. Dr. Pandey is a senior scientist at Space Application Center, Ahmedabad. He has 16 years of experience in SAR remote sensing, particularly in soil moisture. Dr. Pandey, over to you.
Thank you, Ujjwal, and all team members. Okay, so hi to everyone, all the online joining participants. And thank you so much for the nice introduction. Myself, Dharmendra. I'm working in SAC, Space Application Center, ISRO, since more than 16 years. And basically, my area of expertise in micro remote sensing. Currently, I'm focusing on the synthetic aperture radar applications for the soil moisture. And I'm the NISAR science team member and currently looking after the soil moisture activities. So basically, I will be today, because of very short time, it will be very difficult to cover the all aspect of NISAR mission. But I will be trying to cover the overview of the NISAR mission. What is the NISAR mission, and what is the purpose of making such a grand mission with two nations coming together and build a one of the India's global first observatory, radar observatory with dual frequencies are, and what are the applications we are going to touch upon, and how the data can be available to the users, what are the platform where the data can be easily available, and then how to use it. So I will be more giving upon that. So NISAR mission, basically it's one of the first global SAR mission where the two NASA and ISRO has built up a dual frequency SAR mission. We have a launch on last year, 30th July 2025. We have grand launch, and some of the NISR JPL team and ISRO team has been basically we have witnessed this launch on the day of that was very biggest historic day for us, all of us, because last more than 10 years, more than a decade, we have been working on this mission and see the data. So So basically, this is in summary, this is a global observatory which is covering the Earth with 12 frequency observations. Basically, it's L band and S band 12 frequency. The L band basically SAR is being built by the NASA JPL, and S band is being designed by the ISRO. The SAC Space Application Center has built up that payload, and it has a. This is one of the first SAR mission having capability of high resolution from ranging from 6 meter to 10 meter resolution, and then it is also covering the same time the larger coverage. The coverage basically it is covered, the swath area is around 240 kilometers swath coverage. So traditionally, if you see that traditionally, if you want to have a larger area, basically you have to compromise with the resolution, spatial resolution, and if you want to have a very fine resolution observations, you have to compromise with the coverage, the swath. So the NISAR is the first mission with the very new mode of observations, which is called SWIP-SAR mode. So this SWIP-SAR mode basically is capable to provide the high resolution observations, SAR data observations, as well as the very large coverage area. So this is what we are basically trying to get it. This is a small animation. I want to show you how we are operating this NISAR in the orbit. So basically, there are multiple, in the right side, there are multiple L-band antennas are there, L-band and S-band antennas are there. And there are multiple feeds are there. So basically, when we transmit the signal, we basically use a complete aperture of the antenna. And then when we transmit a signal, it is covered using the complete aperture, and then it cover then after the reflection, the waves coming throughout the 240 kilometers. And then because it is a radar, we get reflection from multiple times. So there is a time gettings are there, and then every reflections are getting the particular specific receivers. What we have, this kind of receivers are there. So basically, this is the way we are basically getting high resolution as well as the larger coverage, more than 240 kilometers coverage is there. So these are basic animations to show you how the data is being captured and how NISAR operate in the orbit, and then data is being captured, and then we get a very high resolution image with a very large coverage area. Now, as far as the global coverage is concerned, basically this is the first mission which has a very large global coverage with multiple modes. So there are many modes are available basically to cater to the different science objectives. So this is the first global mission having multiple science objectives, and these science objective has a different goals. So in order to cater to the goals, basically we have a different modes. So depending on the requirement of the applications. So if you see in the India, basically this is a different colors. These different colors showing the different modes. Whether we have a L band or dual frequency observations, we have a high resolution mode, we have a dual polarization for full polarimetric data observations. So a lot of things are there in this. So this is kind of a word coverage in the ascending node. And this is the descending observation. So basically in satellite observations, we have one node is called ascending and descending. So descending, we have a very good coverage. And here also we are covering a very large area, including the India. So Indian, basically we are getting the dual frequency observations, L plus S observations, which is very useful for improving the land use land cover classifications, high agriculture applications, cryosphere applications, and earth observation applications. So that is a whole observation plan. And if you see apart from India, we have a multiple continents are observing in different modes. Like in US coastal water, we have a multiple modes, different colors and different modes are there. And these informations are already available publicly in the NISAR user handbook, we call it. It is already second edition has been released by the NASA and ISRO. So you can, if you want more detail about the coverage plan and how the particular observations plan is being designed, all details are given in that handbooks for the user community. So it is publicly available. Maybe later on I can share with the link also in the same group so that you can have a more detailed discussion on this if you anybody interested. So if I'll directly go back to the level of product available from the NISAR mission. So in any satellite, as you are aware about the any satellite, there are multiple levels are there. So we have a level 0 in the similar form. NISAR, we have a data product in level 0 raw science products. In the raw science product, basically is mainly the raw science telemetry, raw science radar signal data is there, which is not the user, mainly for the mission people. And then we have a level 1 data. So level 1 data, because it is a centric aperture radar data, we have a range SLC, single look complex data sets, which is very good for polarimetric analysis as well as the interferometric SAR processing. So we have a very good suite of interferometric products, as well as we have a level 2 product, which is called polarimetric products at 10 meter and 20 meter resolution. And this the most usable product is the level 2 GCOV, which is called the geographic georeferenced covariance product. So basically, this is a product which is we basically cater to multiple applications, and this is available at 10 meter resolution and 20 meter resolution, depending on the kind of modes used in the data. There are multiple suite of interferometric products are available. Like interferometric, the NISAR interferometric is quite useful for deformation studies, the line of sight deformation, and also the mapping the earthquake prone areas, how much deformation is going on. So this kind of product is going to be used for the this interferometric SAR applications. So there are three products are there where we have a offset products, we have a wrapped phase interferogram products, we have a unwrapped interferogram products, and for each scene. Apart from this level 2, so since level 0, level 1, 2 basically is a mission product, data product, and we have a level 3 large area mosaics are available. So suppose some applications where we want to have a large area mapping, where one scene is not enough to cover the large area, we can go for the level 3 product. So where the mosaics kind of data will be available. And the most important levels is the level 4 science product. So basically here the science team, since more than 10 years, we have been working on the what kind of science product we can define. So we have defined a science products, which will be like a kind of analysis ready products. And it will be highly useful for the community, and they can directly use for their applications. So we have a list of products. Now come to the data access, where we can get the NISAR data. So there are two major portals are available where the NISAR data will be hosted and disseminated through this portal. So from ISRO side, we have a Bhuniti portal. Maybe most of the users might be aware about this Bhuniti portal. And this Bhuniti portal, basically you can go and you can visualize how many sets are available. And then apart from, so all the L-band, S-band data over Indian coverage will be available from the Bhuniti portal. Apart from Bhuniti, we have also the ASF DAC, Alaska SAR facility, which is basically managed by the NASA JPL. And then this portal, basically, they are going to host all the L-band data product from the global perspective. So this is the combination of that. Whenever you need, so today I will be more demonstrating from the Bhuniti portal, where how to go and access the data. And the good news is that recently, just 1 week before, we have released the all the regular data product from NISAR from level 0 to level 1, level 2. And this data is available for the users, and they can use for their further processing and analysis. Now come to the science. So basically in NISAR science objective and plan products, we have multiple scientific themes, starting from the hydrology and soil moisture, where I'm the leading from the soil moisture perspective. We have a solid earth, where we are more focused on the deformation because of the plate tectonic movements, what kind of deformation is going on. Then we have a natural hazards and disaster management applications, coastal and ocean, and then cryosphere, Himalayan and polar. And then we have ecosystem, forest and agriculture. So NISAR perspective, NISAR mission is going to cater to multiple applications centered over these themes. I will not go into detail of these key science objectives, but I will more touch upon the focus on the this science product, what we have defined. And this science product basically is will be the operationally available from the for the users. It is mostly kind of analysis ready product. So kind of I will more focus on the surface soil moisture product. So this surface soil moisture product will be like, it will be first of its kind, where we get 100 meter soil moisture product over India every 6 to 12 days. So that I will show you that. So this is a list of products will be available from the Bhuniti portal also. We have a forest above ground biomass, which is quite essential for the carbon mapping and how much carbon pool is there over the forest area. Then we have a forest disturbance product, mangrove cover, active crop area, which is very important for the agriculture applications. Then we have a surface water extent, where we can see how much area has been inundated because of the heavy rainfall and other activities. Then we have some set of cryosphere product like wet snow cover, glacier facies, ice velocity fields, and deformation maps. And then we have a ocean surface wind also product will be available as a ready to use data sets. Now, this is some, I want to show you some of the recent images, early images, what we have been already published in the public domain. So this is the one of the, no, we have S-band hybrid polarimetric image showing mangroves and other land use in Godavari Delta. So this is a complete scene where we are showing the subset of this one. So here, if you see, the red colors are mostly basically the urban area and then rice fields and paddy fields, and then the green color showing the mostly the vegetation because of the volume scattering. So most of the vegetation is, these are the vegetation, and then there's the river bodies are there, river channels are there, river Godavari, and you can see. So this kind of RGB images also we can form and see, that is good for interpretation and analysis. There's another example where we want to show you the this paddy fields in the Brahmaputra River in Assam. So you see a lot of Brahmaputra River and the water bodies are basically blue color and dark color is there, and the lot of features and different land use land covers are basically very good. And this is very high resolution image actually. So every targets we can easily see and differentiate. Now I will come to the back to this because I have a shorter time. So just quickly, I will go to the Bhunidhi portal. So basically, maybe you can see that you just search on the Google the Bhunidhi portal. Go to this Bhunidhi browse and order. So all the data I will show you how the data is being cataloged and stored in the Bhunidhi order. You go to the Bhunidhi. So this kind of page will open. So this is the page where you can see, okay, so there's the information called NISAR S-band data collection has been released, and it is available from 8th of July. Now, I know most of you might be aware about this portal, but I will give you. The Bhunidhi portal, basically it is freely available to every users. You can go and get registered for this, and you can get download the data freely to any of your applications. Now, if you want to search for last 12 days, how much data is available, just go to change the data range. So there's a data range, if start date to end date, just go there, and then you have to go to the satellite. So there are filters are available, multiple filters. You need to go to the satellite, and then there are multiple satellites are available from the NRSC and Bhunidhi portal. So you just go to the NISAR, just have to check it. So NISAR will come. Then you go to the satellite sensor, and there is a open data direct download facilities are there. So basically, I'm looking for level 2 GCOV. So this is called NISAR_SR. So basically, currently we are hosting the S-band SAR images. Soon we will also host the L-band SAR images. So you can also get the L-band data. Now I will give you the S-band SAR how we can access. So this is the option NISAR/SR GCOV level 2 you can access. Then there is a advanced filters are available. You can see, but right now better to avoid it. And if you go to the right side, there's a marker. You can select the India, how many. So it will show you how many scenes are available right now in the last 12 days. So see, this is the kind of frames are there. So this is the one track in ascending, okay, and this is a descending. So if I go to only the ascending, maybe I will make it only descending one. Otherwise, it will get confused. So I'll see only ascending. So there are filters which you can use to sort it out your data sets availability. Now you see, these are the ascending passes are available, the last, and if you any data, you can go and suppose in Gujarat, I'm going to get this data over the Ahmedabad. Okay, so I'll go to this frame. So this is called one track and multiple frames. So it's kind of a scene. So you just click on this, you get this highlighted this in search result, you get the multiple scenes are available. Just click on this local view. So this is the metadata information. This is a quick look image of the data. Okay. So we are here actually somewhere sitting. This is the Ahmedabad city. This is a quick look image of the single HH polarization SAR backscatter information. You can see this is the quick look image, very high resolution data, and some metadata information also available. So you can download the download metadata information. So this metadata, you have all information about the scenes, when the data is being acquired, the generation data time, when the data is being acquired, what is the satellite, what is the number of dimension, what is the number of pixels, everything is noted down here. So you can easily just save it and you can maybe make it this one like this. Just save it. So you can get the band meta. So this is called band meta information. Now go back to this one. Now suppose you want to download it, because for downloading you need to go for registration and the login. So right now, if I want to put in the card, it will not go because it asks for the login. So if you have, like I have my access, you can just make it use your credentials to log in it. So you will be able to put your required data in your card. And once the data is in card, like you wanted to put this data in card, this one Ahmedabad, this is the Ahmedabad. Okay, no, this is the below one. This Ahmedabad data. So I want to put it in card. Now this is added to the open data card, and go to the card. Now see, this is the data is now it is showing the card, but you have to confirm it. Once it is confirmed, the card has been confirmed. If any data products are tagged, delayed, it will be available. So no, so the green circle means it is available for downloading. So now if you just click on this, the data size is around 11 GB. You will start downloading and you can save it in your local system. And currently the data, now this is the data which is being downloaded. The one part is that the data is very high resolution. So the data size is around 11 to 12 GB, 11.2 GB. So it will take time, but at least you can download it. Now for this, I have already downloaded some data sets. So we're not going to download this again. I will just remove it. So this data now this kind of sample data you can download it, and this data is currently in H5 format, SDF5 format. So if you want to, suppose today I'm more focusing on how you can read this data in QGIS software, okay, which is open source GIS platform. So now the major issue is that the currently QGIS doesn't directly read the H5 if you don't use the Python this console. So what happened? We need to do a little bit tweaking. We can go to the data. So what happened? Currently the data is in I have sample data. So the data is in basically is in the .h5. So you have to just change it to the .nc, because nc QGIS normally it is directly read it. So you have to change the extension of the file, make it from .h5 to .nc. Once it is done, now it is highly compatible with the QGIS. Now open your QGIS and then you go to the layer and then add layer as a raster. Okay, add raster layer. So because it becomes like a raster. Now I'm going to the same folder where I have a sample data downloaded sample data. I will go to the sample data which I have make it a change the extension. So this is the L band data, and NISAR L2 is the level 2 L band data. I have make a change with .nc. Now this .nc, it will be directly, I will add it. Once you add it, you will get multiple, because the H5 have a multiple groups are there. So currently, because of the RAM constraint, limited RAM constraint, I'm not going to load the whole data set in the my system. But I want to see what is the HH polarization and HV polarization, two rasters. I just select these two and then I will add layers. So these two layers will be added to my workspace, the layers. Now, for the time being, because I don't want to capture the whole RAM and then it will be hang actually. So just close it. So now we got that our level 2 layers are there. One is the HH, that is called the HH backscatter image. And second is the HV component. Now, if you click on this, basically, if you click on this, the properties, basically you are not able to see anything coming. So what we have to do, basically you have to make a some kind of min max value setting so that the extreme values will be avoided. So I have to make it this cumulative so that the ranges will be coming to the. So this is currently it will be a grayscale images actually. So you have to make it a cumulative count. Maybe you can also change the min max values so that the histogram could be within this one. Then zoom to layer. So depending on the RAM availability, it will take some time, but it will show you some images in this one. I have added some from web. I have added some quick map services from the Google Earth, Google Labels and satellites. So maybe I can close this one. It is taking more time. Just a minute.
Yeah, Zoom also takes a bit of RAM. So
Yeah, that's what actually it is. But anyway, I will just summarize it.
yeah, I was trying on my computer as we were doing it, and it rendered fine on my computer.
So actually, it is in QGIS. I have found it very good actually, and you can try so many things in the NISAR data actually. If you have a sufficient RAM, at least minimum maybe 16 GB minimum, you can easily work on single channel or dual channel. But not because normally in office we use more than 128 GB RAM. Then well sufficiently we can run this processing. Otherwise, it takes a lot of RAM because it's very huge data. 10-meter pixel spacing is there.
Maybe while you are waiting for your thing to load, let me just quickly show what it looks like on my QGIS. This is what it looks like. So I loaded the same scene.
Yeah, right. Yeah, this is correct. If you go to the top one, the north part, this airport is there. You see the air strips. So in the grayscale image, basically the radar, basically it's a smooth surface. You get very low basket or low reflection actually. So it looks like a very grayscale low values, dark radar returns. And the urban area, the buildings and other man-made structures gives a very high return. That's why it is a more bright. So in normal radar textures, we get very high basket and low basket from the water bodies smooth area. You see the Sabarmati, the river, and all the bridges. The bridges comes are very distinctly are able to see the bridges, right? Because of a double bounce effect. So the bridges are concrete structures, metallic structures. It gives a very good return. So this is a very basic SAR images, single polarization image, and then you can also add the cross polarization images. If you have not worked on the SAR images, maybe offline I can help you to understand, and we can if you have any doubt, maybe we can maybe what we are planning, maybe usual we can later on we can make a very dedicated session on the NISAR data processing, especially some focused applications. So this is the full scene of L-band NISAR image, single channel. This is HH polarization, and then corresponding we have a HV polarization. So this is the basic one. So now what we can do, maybe you can zoom it, and takes a little bit time. You can see, and maybe we can see zoom to native visualization. You can see very good features, and then a lot of functions we can do in the raster. Actually, go to the raster. You can extract the. Suppose you want to focus on some small subset of the whole image. You can go and clip it to the extent. If you have some rectangular body, maybe some kind of vector layer you can do that all. I've been now trying to use QGIS extensively for this kind of processing. Maybe later on I can make some kind of user manual for also this. So I think because of time constraint, I think this is all I want to show you, because this RAM is taking a lot of time. So well, it is okay now. You can maybe I can take some questions if participant has any questions. And I look forward to have more dedicated session. Maybe in future we can plan with the help of everyone, if people are interested.
Sure. Yeah. Thanks for the overview and taking time for introducing. I've been waiting to play with NISAR, but whenever I saw this H5 download, I said I don't know how to work with it. But this is a very simple trick that you showed us, and it was able to work.
Yeah.
So I have one question. When will the soil moisture product be available?
Yeah, raise a very good point. I have some sample products. I will show you the product, how it will look like soil moisture product. So this is the same Ahmedabad region. I have generated some multiple soil moisture products, and this is the January 29th. Yeah, my screen is visible now.
Yes.
Yeah. So just a minute. Let me first load it. Actually, then I will talk. Layer, add layer, rest. So basically, we now level 2 products are publicly released. Now within a couple of maybe within a week or 10 days, we are going to release this soil moisture product also very soon. I mean, we are aggressively working on that, and this product will be the one of the game changer, because this kind of products are not available till now from any mission. So I will show you some sample products from soil moisture, how it looks like, and it will be get amazed. I have add to the layer. It is there now. The dates are maybe different than what I have used. So this is a level 4. I'm just putting uncheck. Yeah. So this is the soil moisture product. It's like white and gray. So what happened? There are some offset are there. You have to go to the properties, make it a transparent. There's a -999 is the transparent value. Now this is soil moisture product of the 29th January 2026. And if I want, this is a grayscale image. I want to go and put some colors so that you can easily you can see what is the soil moisture of the area. And I will also add this Google satellite image so that you can also see. I hope it is visible now.
Yes.
So this is file. This is the 100-meter soil moisture product from the NISAR S-band SAR images acquired on the 29th January 2026. So basically in the winter season, mostly what happened, this part is highly basically winter rice and a lot of irrigation happen in this area. That's why you see very large soil, high soil moisture cases. If you have a pin, if you point these values, you can get the values too. So this is the range of basically the values are around the just a minute, 42%, 45%, 46%. And this area is mostly dry because here irrigation is not happening. So it is totally rain-fed areas, basically. So I maybe because of time, I may not be able to show you the time series. We have done a very good time series actually, where we can see how the time series. So if you allow me just 5 minutes, can I take 2 minutes? I have an animation actually to show you. Recently, we have done this time series over Ahmedabad, and it looks very. So basically, what we're trying to do, this kind of 100-meter soil moisture product. If you want to understand the spatial temporal dynamics, the time series data will be highly useful, and it makes the. I have this animation of the NISAR. This is the first time series product, which will soon will be released by the community. So this is the Ahmedabad region. See, we have total eight cycles of soil moisture over Ahmedabad region, and how the soil moisture varies. So we have on the right side, we have done some analysis. The ridge plot is there, where you can see how the soil moisture mean and destined variability is changing. You see, this is the pockets of region which changing from the November 2025 to the March to February 2026.
So then there is a question, what is the unit of soil moisture? Can you talk a little bit about that?
Yeah. So currently this soil moisture product, basically this is the volumetric soil moisture in meter cube by meter cube. It is the absolute soil moisture, not the relative one. Okay. So that is most of the people use it for this one scientific community. So this is the volumetric soil moisture. So it gives a volume of the soil moisture available within the volume of the soil. So basically when you say here you say the dry 0 to 0.6 is the maximum range. And the yellow color shows the low soil moisture where the 10%. So if you want to convert into 10%, simply multiply with the 100. So you'll get it in the percentage. But normally we talk about in meter cube by meter cube. So most of the pockets, so this is what we are, the product. And maybe I will share more detail about this soon. So we will release all the ATB documents, all the user documents, handbooks for this soil moisture product, and all the details about this one soon within 1 week or 10 days.
Great. There is one more question. For which areas is this data available now?
Regarding the soil moisture or regarding the level 2?
I guess level 2.
Okay. So
no, the soil moisture.
Soil moisture, okay.
It was specific.
Yeah.
Okay. So currently this soil moisture product is not publicly available. We are soon going to release for all over India and also global cal websites. So the data will be available for all over India, all the Indian land masses like this. Every 6 days, because we are trying to process the ascending, descending, both the process. So we can have every 12 days, you have 2 observations, 2 soil moisture product over a particular any location over India.
All right. There are lots of questions. I think
people, if you have any long questions, maybe you can mail to me, or maybe you can compile and then share it with me. I will be happy to answer that.
Sure. Cool. Thanks, Dharmendra. Great. It's very exciting to have this soil moisture data finally available and looking forward to that. So thanks for your time and giving us the presentation.
It's my pleasure.
Move on to the next talk. Janvi, you can introduce this.
Thank you so much, Dr. Pandey. So the next person is Mr. Lodha, Krishna Lodha. He is the founder of excuse me.
ObserveEarth.com.
Yeah. I'm so sorry. It's an Earth observation platform which not only provides access to satellite datasets, but 80 plus spectral indices, weather forecast through a very easy API for geoanalytics.
Hi everyone. Good evening. My name is Krishna Lodha. I am founder of Rotten Grapes Private Limited. We are a geospatial company, and we have one of our products known as ObserveEarth.com. And today I'm actually really happy to present the ObserveEarth plugin that we have made, which will be available for everyone to access for free of cost. So allow me to share my screen so that we can have a quick look at that. Like before we deep dive into QGIS, ObserveEarth.com is a simple to use API as a service, which allows you to access satellite data, Sentinel, Landsat, MODIS, Sentinel-1, Sentinel-3, Sentinel-5, weather data, digital elevations directly as an API. We started creating this because while working with multiple clients, we realized that people do not want to maintain the infrastructure. And that was the gist of it. I will not spend a lot of time over there. But the idea was very simple that I give you AOI, you just return me the data, and you do. And we wanted to make something that is commercially usable, apart from using Google Earth Engine to do the same thing, but you cannot usually use it for any of your commercial products. And now, of course, the license have changed. Coming back to this, we have developed a plugin that you can actually use by just simply going into plugins and searching for ObserveEarth. You will see this icon, and you can just click on install plugins. This is something that that is still like in really early phase. So we have only launched one version of it, and we are currently working on improving it to add more indices and to add more capabilities. Once you install it, you will see ObserveEarth plugin under plugins, and perhaps the icon will pop up somewhere on your toolbar as well. And this allows you to select the polygon source. So currently it only works with polygon. In the future, we will also allow user to select a point and select the buffer distance and generate the polygon on our own. Once you select the source as a drawn canvas, at this moment I have no layers, then I can select the provider. Currently I see Landsat and Sentinel-2. In the upcoming version, you will have more providers. And then you can select the index that you're interested into. Let's stick with NDVI. Then we have some date presets available, which we find makes the life of user very easy. So if I want this week's data, I can just search for that. Or if I want custom, that's totally fine. So I can just go in any date range that I want. And then I can select maximum cloud cover. Because we are working with Sentinel-2, cloud cover is possible. So I'll just select 5, and let's say that if I draw some random polygon, then it will simply search for all the images available between the from and to date. So I can see that the date is available from 3rd of January all the way up to 4th of June. And I can just load the layer by clicking on load layer. So when you work on a smaller area, generally like a single tile will include everything. So as you can see, NDVI is directly available to us. But when it comes to working with, let's say, a large area, perhaps you might need to clip multiple tiles together. And in some cases, you also want the facility that I want a mean for a month. Let's say if I'm interested into getting the entire data of January as a single, as a single TIFF. So in that case, what I can do is I can just click on load mean for the index. And then what it will do is it will look for all the images available. In this case, 9 images are available. And it will process all these 9 images and finally calculate the mean and give you the mean. And this process, again, QGIS is a desktop first software. So the entire timeline to do this will depend upon how big of your area is, how many dates are you requesting, and what kind of system that you're running. So I'm on M1 Max, and I've selected almost 9 images. So sometimes it will directly go from 3 to 9, and then you will be done. But you will be able to get the mean of the selected dates also. So now you can see that we actually went from 3 to 8. And here is the index of the entire month. So this is something that we are building right now. And even if I have, let's say, the existing file with a polygon, I can just go to ObserveEarth and ask it to use that polygon. And again, the process would be same. Let's say if I'm interested into NTWI, for last 1 month, I can request. It looks, yeah, because it's raining cats and dogs here in Nasik. So there are no imageries where the cloud cover is less than 5%. So these kinds of things are also integrated into this. The roadmap for us is to obviously add more indices, more providers, but also to allow you to use this in your workflow of your existing QGIS, so that if you have a file with hundreds of farms, essentially you will be able to generate hundreds of NDVI or any other index for that matter of fact for a particular date. The motivation behind building this is that if you're interested into NDVI, you should not have to jump through the hoops of, first of all, getting Sentinel, clipping it for your area, doing calculations, etc., etc. That's all. That's all that I wanted to share as an effort that we have done, and we are open to hearing more from you guys. I would request everyone to give it a try. So you can just go to plugins and click on ObserveEarth, and it will not hurt to put good ratings also. So please make sure to put the ratings as well. And if you're interested into checking out the code, you can obviously go to the code repository. It's public. Leave a star, leave a fork, and feel free to open the issues as well. So yeah, I think that's all from my end. Thank you.
Yeah, thanks,
Can I say
Krishna.
something? Can I say something? Sorry to interrupt. Just one thing.
Sure.
The big thanks to Krishna actually, because I'm just yesterday I had started to build this kind of plugin, and I recently found it is already there. So you had saved my lot of time. Thank you so much. Thanks.
Feel free to give it a try. I'd love to hear your opinion on the same.
Sure. Thank you.
Yeah.
Any questions for Krishna?
Krishna, could you please also share the APIs that you have on Observer?
Sure. So let me share my screen. So if you just head over to observer.com, you can actually look at the API docs. It's a fairly straightforward swagger. So we provide air quality. There's something amazing and really interesting that we have built with our clients is that's alerts. Because generally the kind of client that we are dealing with, they are working with 10,000, 20,000 farms in one client. And it is absolutely impossible for them to have a look at what is happening on the farms on a daily basis. So what we did is like, you can actually, let me actually show you that. So you can go to the ObserveEarth account and you can set up a notification stating that for a particular farm, you can set some kind of name and say that, okay, monitor this farm until, let's say, and it can be any date, let's say 30th of July, Sentinel-2, and if the NDVI or let's say if NDWI is less than something, then just drop me an email. And this can be n number of conditions that you can play with as an and an or. And that is something that people absolutely loved. And yeah, apart from that, you can check out the API docs. It's a fairly straightforward guide. And if you need any support, you can always reach out to us. We'd be happy to help you guys out. We provide multiple things like the least, I would say, the basic thing that we provide is that our API does not expose the data as a pixelized Sentinel-2, but we actually run a bilinear algorithm so that it looks much more cleaner, much more better, and provides you much more better insights as well. So yeah, have a look at it. You can sign up for free. You don't need to pay. No need of putting credit card. You can just check out the APIs for free of cost.
Thank you.
There is one more question. Will the baseline correction is done in S2?
Yeah. So we are in both cases we are using planetary Sentinel-2 data. So baseline correction formula after 2022 is some date, I think, that has been applied, but that has been already taken care. Currently, we are working on a way that we are actually putting two I would say sources. So we are using Element 84 as well as planetary, so that even if let's say for some reason one goes down, you will still get the data. But baseline corrections have been already done. If that answers your question.
All right. Thanks, Krishna, for the demo. Looks pretty cool.
Yeah. Thank you.
We have the next speaker. Janvi, you can introduce.
Thanks, Krishna. So our next speaker is Mr. Manas Barve. Manas is an environment and GIS professional. He's currently working as a senior GIS analyst at MRSAT. Manav, over to you. Sorry, Manas.
Thank you, Janvi. Thank you, Ujjwal sir. Thank you everyone for attending. I will just quickly share my screen. My plugin is really basic plugin, and we actually build it for our internal purpose. So right now I'm working as a senior project consultant in MRSAC GMIDC Sambhajinagar. and we are working on canal updation projects. So our project mainly deals with identifying the canal network and digitizing it and applying some special analysis if they require. And to do so, we actually need many small processes. Like if we see this, this is the simple network of Upper Dudna channel, and we have dam line, we have some canal network, and some hydrostructures around it. So the major problem we were facing was giving the chainage values to these hydrostructures. So basically, chainage value is something that is we will measure it from imaginary line. In our case, it was in a canal line. So if the head regulator is from start, it should get 0, and so on. If something is on 100 meter, then it should get 100, and like this. So initially, what we used to do, we used to plant one particular point, then snap it on the canal network. We split the line, we get the distance, we add that distance to the attribute table, the field. Then again, we merge that line again, and we do the same process for n number of networks, n number of structures which are available on that network. So it was taking too much time. So actually, I tried to build some small Python plugins, some Python codes initially, and I tried it on my system itself, and it worked very well. It was saving me time, lots of time. So then I actually use to do this for other team members. Then I realized I should make a plugin so that everyone can use this. So this is my plugin, Chainage calculator. So here I have dam line as well as I have a canal line. So I will select a canal line. I said okay. I have dam point. Before that, I just show you the data. So these are the hydrostructure details we used to fill. So you can see the chainage by WRD, chainage by satellite calculate, and this is the blanks thing which we are going to click now. So this data we used to fill by manual processes, and this data was given by the WRD officials. So this kind of data we are right now collecting. So there are more. So because of some project restrictions, I am not allowed to show all of the data. But the satellite derived chainage we used to calculate manually. When we digitize something, we actually the process I have actually said before, the manual process. This data was given by the WRD officials. They give us the list, the name, and chainage thing. And this is the field which I'm now right now going to fill using this plugin. So again, I will select. I have two line layers. One is a dam line, one is a canal line. I will select the canal line. I said okay. There is only one point layer, so I'm not getting any other. So I will set okay. Then the attribute column where I want to calculate the chainage, and I'll just hit okay. So it's done. So again, you can see we have got pretty close to the readings which manually we used to fill. And right now these are 54 structures, 53 structures. So 53 structures less than a second. So this thing used to take us 15 to 20 minutes. And if we change, and most of the times what happens, the network is like this. So if we change some directions, then whole chainage we used to calculate again and again. And these are just 53, and there are more bigger networks. Like some networks have 100 plus hydrostructures. So it was really tedious for us to actually work on this. And this was not something like brainy stuff. This is manual labor work. So we actually love this tool. So it was actually good initiative, and I actually thank Special Thoughts, because how to convert a Python plugin, Python code to the actual QGIS plugin, it was really explained very well, and it helped me a lot. So thank you guys. So, this was from my side.
Yeah, thanks, Manas, for the demo. And I think it's just amazing to see that, when you have a workflow and you have tools like QGIS, you can automate that. And I think it was good to see that plugins need not be just public plugins, but many of the plugins are just internal plugins that you use it for automating your team's workflows. And again, this is to inspire others who are in a similar situation. You can also now think of automating your workflows. Any questions for Manas? I have a question. How do you distribute this plugin to your colleagues?
So I shared zip file and they use install from zip, and now everyone is using it locally because it is actually focused only on the canal network and other stuff. So I didn't found it means till now, but let's see how it goes ahead, because I have some plans to actually upgrade this or add some new features to this ongoing plugin. So let's see how it goes.
Okay.
So, are there any required attributes for this calculation, like the table that you showed? So, the attribute table that you showed, is there any required column that needs to be in
Yes, 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 yes. We have to provide that required column. We have that column right now with us, so we know where we want to put that value. So that's why it's easy. So we require it.
No, like from the data that you are providing, the WRD data that you are providing. So, is there some value data that is required from that side?
Sorry, madam, I didn't get
Input data.
your
Input
question.
data.
So input data what WRD is giving us is like the list of they are just giving us one PDF file which include one to whatever the number is this, and each number has a particular hydrostructure name and a chainage. That's it. So we have to figure it out if chainage is on that chainage structure exists there or it is not existing. Because big structure we can easily identify using satellite images, but small structures like outlets they are not really visible. So we have to believe on WRD's on-field data. They do actually do on-field surveys like line surveys and other stuff to get that data.
There's one more question. Are we able to plot the Chinese lines on the drawing?
Uh, on the drawing,
Maybe Onkar, you can clarify.
See, if the survey person is required the Chainage drawing, then can you plug in plot those lines with the intervals?
No, 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 no. This plugin is just to update the attribute table based upon my existing drawing. So it didn't draw anything new. It is just use the existing data sets which we have drawn earlier or which we have drawn earlier, and we are going to use that again. So no new structures, but this is a good idea. I can actually work on something like this.
Thanks, Manas. We are coming towards the end of our planned time. Before we end the session, if you would like to present at our next meeting like this, we do this every month. We try to do it on third Friday of every month. So if you like to present at the August meeting, you can fill out this form and present. It could be anything related to QGIS if you want to share. And again, this is an open community. We want to learn and share from each other. So fill out this form and love to hear from you. We have a event team which will review your submission and we'll get back to you. We are over the planned time, so I would like to be respectful of everybody's time and end the session. So thanks to all the speakers for the presentations and thanks to all of you for attending. We'll see you at